Hey everyone, I'm making this video to help you out with problem number 15 in section 11.3. What the problem describes is that there's a man who's up in a fire tower. So he's up off of the ground and he's looking out into the forest, in two different spots in the forest. Down in the ground there's fires that he can see. So you have to try to think three-dimensionally. He's up off the ground and then looking out and down and try to draw a picture that way. I'm going to try to show you with my pen and this marker kind of what's going on. So if my marker is the fire tower, and then the guy's at the top of the fire tower, he's looking out, his line of sight will be this pen. If my arm is the ground, can you see how that forms a right triangle? The tower and the ground, there's a 90-degree angle between them. So one of the big things to notice in this problem is those right triangles. So I drew a picture. This line right here is the fire tower. That's 300 feet tall. And then there's the two fires. If I draw a line connecting the fire tower to the fires, this line's running across the ground, and therefore that has to be a 90-degree angle. Even if it doesn't look like it in my picture, it's got to be 90 degrees. Same thing here. From the ground to this fire, this has to be a 90-degree angle as well. All right, now, the other thing that we're given in the problem is the angles of depression. So we know that to one of the fires, the angle of depression is 1.3 degrees. So that means from the top of the fire tower here, off of the horizontal, this is 1.3 degrees, which actually makes this 1.3 degrees as well, because they would be alternate interior angles. And then this angle over here is 2.5 degrees, which makes this 2.5 degrees right here. All right, so I'm going to pull these right triangles out of the problem. So there's one fire. I'll make this the one that's 2.5 degrees. This is 300, right? What we would like to know actually is the hypotenuse here. So I'm going to call that x, this length, the distance from the man to one of those fires. And then I'm going to make another triangle, 90 degrees here. Oops, that was 90. This will be 1.3 degrees. This is also 300, and I want to know this length here. I'll call y. Now, can you see how there's a third triangle in the picture? If I connect the two fires together, we have a third triangle that's not a right triangle. I'm going to draw that triangle. We know this angle is 117 degrees. This is what we're calling y, this is what we're calling x. And what we really want to know, I'll call this z. Because the question asks how far the fires are away from one another. Alrighty, so let's go ahead and set up how do we find x and y. Well, since they're right triangles, we can just use our simple right triangle trigonometry stuff. So off of the 2.5 degrees, we know the opposite side, and we want the hypotenuse, so we want to use sine. So sine of 2.5 has to equal 300 over x. Same exact thing over here, except it'll be sine of 1.3 degrees has to equal 300 over y. And then solve both of these. So if we multiply both sides by x, we get this. Divide. So x is approximately, let me type that in the calculator. So 300 divided by sine of 2.5 is 6,877. Okay, so that's x, which means we know this length right here. And then we solve for y in the same way. Y is going to end up equaling 300 divided by sine of 1.3 degrees. So we type that into the calculator. And we get 13,223.2375. Okay, so now we know this. And the final thing that we need to figure out is what is z. So I'm going to leave you with trying to figure that out, but I'll tell you what to do. We have a side angle side case, which means that we can use the law of cosines. So use the law of cosines to find z. And then you'll be done.